Alright, so let's show that this thing is alternating. So let's plug in 1, I get -1 over 1 plus 1. Plug in 2, I get 1 over 2 squared plus 1. Plug in 3, I get -1 over 3 squared plus 1. Plus 1 over 4 squared plus 1. So this is just going to be -1/2 plus 1/5. That's -1/10. Plus a 17th. Feels alternating to me. So it looks like an alternating series test candidate. Let's check my limit. Clearly this thing's going to go to 0. This is not a L'Hopital's rule candidate because my numerator is not infinity or 0, it's just 1. Clearly 1 over anything very large goes to 0, so that's a check. Is my series decreasing? Well, hopefully everybody's okay with n plus 1 squared plus 1 is bigger than n squared plus 1. So that as I flip both sides, I get n plus 1 squared plus 1 is 1 over n squared plus 1. That's an easy decreasing. That's a check. Sorry, that ran out there, but I'm sure you figured out what I was talking about. Prove convergence or divergence. This is a little ugly one. So this is n squared plus 1. It's not really a series that we know, but I do know that I can compare this to, there's nothing really I can do with 1. The denominator, clearly n squared is much bigger than 1. I can compare it to 1 over n squared using limit comparison test. So limit as n goes to infinity of 1 over n squared, 1 over n squared plus 1. I flip and multiply. I get n squared plus 1 over n squared. Multiply top and bottom by 1 over n squared. I get the limit as n goes to infinity of 1 plus 1 over n squared over 1, which that equals 1. So I've shown that this series converges without the -1 using limit comparison test to p series. P is equal to 2 p series convergent. So I've done that. And the last thing is conditionally or absolutely. Well, this series here converges because this one converges by limit comparison. I should probably write that down here. Limit comparison test. So therefore, this series here converges absolutely. I don't need the positive or alternating signs to make it converge. So absolutely convergent. So there's lots of things that I'll be looking for here. Number 1, I look for the limit as it goes to 0. Number 2, I say I show that this series is decreasing. Number 3, I show that this series is convergent. This one took a little bit longer. I had to do a limit comparison test to show that this series converges by over here by p series test. P series convergence with p is equal to 2. The only thing I forgot to write down is alternating series test. So that was a lot. That was a big one.